Hi, this is Abhilash, and let us solve another problem. So, in this problem, lead code 200, number of islands. So, in this case, we are given an m into n 2D grid, binary grid, which represents a map of 0 and 1. So, 1 represents land and 0 represents water. So, we have to return the number of islands. An island is surrounded by water and is formed by connecting the adjacent lands either horizontally or vertically. So that means we are given a graph that is a kind of a matrix, and this matrix is comprised of zeros and ones, where zero represents one represents land, and zero is for water. So we have to find the number of components, connected components. In this case, the number of islands. So an island is surrounded by water. That means zero on horizontally or vertically. So the water, that means zero, is present either up, left, down, or right in the four directions, that is horizontally and vertically. So we may assume that all four edges of the grid are surrounded by water. Okay. So this is the grid, and we have to find the number of connected components. So this is one component. Rather, this is only one component. So if we include one, and this entire thing, so this is one connected component. Similarly, over here, this is one connected component, and this is another, and this is another. So three in total. Since we cannot move diagonally, so only up, left, right, and down. So in that case, we cannot connect these two islands. Okay. So this looks like a proper BFS problem. So also this can be solved with DFS as well. So let's try the BFS approach. So in the BFS, we're going to create a function. So which takes this grid, okay, and we are going to create this BFS function now. The vector 2D vector of chars. Okay, so now we have to specify, as usual, we have to specify vectors for calculating the coordinates, that is up, right, left, and down. So this can be done very simply by taking the four coordinates for x and y axis respectively. Similarly, for the y coordinate, this can be done with the help of like this. And we have to create a queue. So we need, for BFS, we need a queue. So this queue will be a pair. So Q will be a pair of the coordinates, that is int and int in this case. And we have to start searching from each and every step. So that means we have to start searching from one, and we have to keep on iterating. So in this case, you can pause the video at any time to think about the solution. So in this case, we're going to need a queue, and this queue is going to be a pair of int and int. So since we have to start from each and every index, that means 0, 0 to m minus 1, n minus 1. So we also have to keep a checking function, so that check whether it is in the matrix. So in that case, we have to first specify the x and y coordinates along with m and n. So in this case, let us write and x less than m, y greater than equal to 0, and y less than n. So this signifies that the particular coordinate is inside that particular matrix and it does not goes out. Very standard procedure for any BFS problem. So first we are going to loop. We are going to keep an answer variable or a result variable as 0. This is going to be our result, and we are going to increment it when each new connected component is found. So here we are going to enqueue each and every point. So enqueue each point, each new point. So for this, we're going to loop I less than m, I plus plus. So let me just also write this m variable, which is the grid dot size, and the n variable, which is grid 0 dot size. So this just variables boundaries in our case. Once this is done, we can use this iteration. And since we are using an adjacency matrix, it is regarded that the complexity is going to be m into n, since we are traversing the entirety of the matrix. So in this case, we are going to increment. That means if that particular value, so let's say grid of I comma j is, let's say, 1. So that means this signifies an island. Signifies an island. Let's say unvisited island in our case. So in this case, we are going to just add up the answer variables because it is a new unvisited island, new connected component, and I want to see what are the connections that can be achieved from this particular input xy coordinate, that is I and j. Now, what I have to do is I have to push this back in the queue, right? Because I have to enqueue this particular coordinate. So let us enqueue this, right? Now we have to use a while loop because at each step we have to take the topmost element of the queue and we have to retrieve that value. So q dot is, if the queue is not empty, then we are going to filter out the top element. So q dot front, and for this we also have to pop the first element. Again, we have to check the new row and column value. So we can rename it as x and y itself. For simplicity, temp dot first and y will be temp dot second. And now we have to iterate. So we have to iterate over possibilities. So possibilities are u, d, l, and r vectors. So we have to iterate through the possible vectors. So k equal to 0, k less than u dot size, k plus plus. Now, since u is initialized over here and v is initialized over here, we can use them. So int temp x gives x plus, let's say, u of k, and int temp y will be y plus v of k. So this signifies that the new coordinates are there. Now we have to perform checking. So this checking is done to ensure that first we have to check that whether point is inside matrix, and the second check is going to be if the value of the point in the grid is 1. So this signifies that it is a connected component, right? This signifies that it is a connected component. So we can do this by applying this logic. So if check in matrix temp x, temp y, m, and n, this is true, and grid temp x, temp y double equals to 1. So this means that this is a connected component. So what we are going to do in this case, we are just going to enqueue that in the queue, right? We're going to just enqueue that temp x and temp y value in the queue, and that should be it. So our complexity in this case is m into n into the size of the queue at each step. So since at each step the queue can have a maximum size of n, that is grid 0 dot size, right? So that will be added to the complexity. So at the terminal point, once this is all done, we are going to return this answer value, because this answer value only gets updated if a connected component is found, right? In all other cases, it does not take that into consideration. Okay, so if we were to run this BFS algorithm, let's see what result we get. So we see a time limit exceeded because our complexity is quite large. So can we somehow reduce this complexity? So in this case, we have missed out on a few things. So one of the most important thing is that once we visit a node, once we visit a node, we have to mark it as visited, because how else are we going to know whether a node is visited or not? So one way to do is that in place, if you want to edit, so we can just mark that particular one in the grid, that is ij, with this value, that is 0. So mark it as 0. So in this case, indicates that this node is visited, or that particular coordinate is visited. In the same way, we can also mark tempx and tempy as visited. So for this grid tempx and tempy, we mark it as 0. So once, if we try to solve this, we'll be getting a result which accepts the particular solution. So let us try to run on this. And for this particular use case, the values are getting correct. So in this case, if we try to solve this particular problem, this test case, and let us, so in this case, the output is going to be 3. Okay, my test case is not correct, it seems. So let me try that again. Okay, somehow this test case is not working. So let me try to submit this and let's try to see the formulation. So in this case, it got accepted. In this case, so we can see that this BFS approach, we are facing a complexity issue, time complexity issue, because we were not marking the cell as, or the particular coordinate as visited or not. So for that, we have to explicitly mark it once it is visited. So in the same way, in this case over here, inside, after this checking is done, we have to mark it as visited. So this is almost similar to the previous problem that we saw, like nearest exit from the entrance, which also applies this BFS strategy. So this is a concept of BFS which is most popularly used for connected components. So this can also be solved with the DFS approach. We will be looking into that in some other variations, and it is encouraged so that you guys can try the DFS approach. That will be all for today, and hope you like this video.